July 10th, 1940, Enfield. The army had nothing left to fight with. The beaches were empty now. The smoke over Dunkirk had cleared. But the silence that followed wasn't peace. It was something worse. Of the 338,000 men the Royal Navy had pulled off that coast, most arrived back in Britain carrying nothing but the clothes on their backs. No rifles, no machine guns, no equipment, just bodies. The British Army had left it all behind. 68,000 vehicles abandoned on French roads, 2,500 artillery pieces spiked or pushed into ditches, 90,000 rifles ditched in the sand along the waterline, 8,000 Bren guns, the absolute backbone of British infantry firepower, lost in the retreat. In 6 days of chaotic evacuation, one of the most powerful armies in the world had come home nearly naked. The men were alive. The army as a fighting force was barely functional, and Hitler knew it. His generals were already drawing up plans. Operation Sea Lion, the invasion of Britain. German intelligence had assessed British coastal defences and found them catastrophically thin. In some sectors, there weren't enough rifles to give every Home Guard soldier a weapon. Men were drilling with broomsticks. Actual broomsticks. Churchill had ordered pikes, medieval pikes, to be manufactured as a stopgap, because there was nothing else. Coastal observers were being issued with shotguns and hunting rifles collected from private citizens. That was the state of the nation's ground defense in the summer of 1940. The War Office wasn't panicking. Panic takes energy. What was happening inside those offices was colder than panic. A brutal, grinding calculation of exactly how long Britain had before the mathematics of the situation became unrecoverable. The answer they kept arriving at was weeks, maybe less. Somewhere in that window, between catastrophic defeat and possible invasion, 2 men sat down in a drafting room at the Royal Small Arms Factory in Enfield and tried to solve the impossible. Their names were Harold John Turpin and Major Reginald Vernon Shepherd. Neither of them was famous. Neither of them was looking to be. They had a single, unambiguous goal: design a submachine gun that could be built by anyone, anywhere, using almost nothing. It had to be cheap. It had to be simple. It had to be fast to produce. And it had to actually work when a soldier pointed it at something. What they came up with in the next 36 days would change the entire character of the war. Shepherd was 52 years old and had spent 3 decades inside weapons design. He was methodical, precise, the kind of man who measured twice and questioned everything. He had seen what happens to infantry when their weapons fail under field conditions, the jams, the misfires, the stoppage drills that get men killed while they're standing in the open trying to clear a round. He had no patience for elegance. Elegance was what you built when you had time. Function was what kept soldiers alive. Turpin was different. Younger, faster mentally. A mechanical mind that could translate abstract requirements into working metal. He had been at Enfield since the early 1930s, producing quiet improvements to existing weapons systems, the kind of work that never gets credited but makes everything else run better. He was the one who could take Shepherd's requirements and convert them into something a machinist with basic equipment could actually produce. Together they were an unusual combination, but the problem facing them was unlike anything either man had dealt with before. Britain's standard-issue submachine gun at the time was the Thompson, the American Thompson, a weapon that had been designed in the gangster era and built to American industrial standards. It weighed over 10 pounds loaded. It required between 80 and 100 precision-machined components. It cost the equivalent of roughly $209 per unit at 1940 prices. At that cost, with that complexity, you simply could not rearm a broken army fast enough. By the time British factories retooled to produce Thompsons at volume, the Germans might already be in London. The Germans themselves were using the MP-40. Lighter, leaner, manufactured through a dispersed industrial system that spread production across dozens of factories to survive Allied bombing. Britain had nothing comparable. Not yet. Not without time it didn't have. So Shepard and Turpin made a decision that most weapons designers would have resisted. They stopped trying to match the competition and started from scratch, asking only the most basic question imaginable. What is the absolute minimum a submachine gun needs to function in a soldier's hands? The requirement they wrote for themselves was almost brutally plain. A submachine gun buildable with stamped sheet metal and basic steel tube stock, manufacturable by workshops with no specialized equipment at the lowest possible cost per unit. No expensive forgings, no precision machined receivers, no complicated lockwork, just a tube, a bolt, a spring, and a trigger group. What they began designing in that room would eventually be named the Sten. S for Shepard, T for Turpin, EN for Enfield. But in those first days of July 1940, it had no name. It barely had a shape. They started with the barrel, 9mm to match German and Italian ammunition, a deliberate choice made for logistics, not sentiment. If British supply lines got cut or battlefield resupply collapsed entirely, soldiers could use captured enemy rounds without modification. The barrel was kept short, far shorter than comparable weapons, just 7.7 inches. It made the gun look almost comically stubby, but it stripped weight, simplified machining, and shaved enough length to make the weapon genuinely portable in tight spaces. Then came the receiver, the steel tube that housed the bolt. This was where most submachine guns became expensive and slow to manufacture. Standard receivers required tight tolerances, complex milling operations, and careful fitting. Shepard and Turpin eliminated all of it. They used simple steel tubing, industrial grade, the kind found in metal shops across Britain. The receiver was machined only where the barrel seated and where the ejection port opened. Everything else was a pipe with holes drilled in it. The magazine housing sat horizontally on the left side of the weapon. Unconventional, but practical. Most weapons fed from below or above. Mounting it sideways reduced the gun's overall profile, made it far easier to handle while lying prone, and allowed the magazine itself to be a simple double-stack pressed metal design produced with basic stamping equipment. The stock was a folding metal wire frame, no wood, no carving, no expensive fittings, just bent steel rod that snapped into firing position or folded flat against the receiver when the soldier needed to move through a doorway, a trench, or the cargo bay of an aircraft. Total strip and reassemble time. Under 1 minute, no tools required. The bolt operated on a blowback principle. Open bolt design. No external hammer, no separate firing pin. When the trigger was pressed, the bolt flew forward on spring pressure, stripped around from the magazine, chambered it, and fired. All as a single motion. Gas pressure drove the bolt rearward, ejecting the spent case, and the spring reset everything for the next round. The cycle rate came in at approximately 550 rounds per minute. Rough. Direct. Mechanically honest in a way that more sophisticated weapons never were. By the second week of July, they had a working prototype sitting on a workbench. It looked wrong. That was the universal first reaction. The Sten didn't look like a firearm. It looked like something salvaged from a maintenance shed. A length of pipe, a few spot welds, a wire frame that a soldier might confuse for a coat hanger. Placed next to a Thompson or an MP-40, it seemed almost embarrassing. Officers who saw it for the first time didn't hide their skepticism. Shepard took it to the range without comment. The first test? 150 rounds, continuous, no stoppages. Then another 100. Then the deliberate contamination trials, Mud packed into the ejection port, sand thrown into the action, water poured directly into the receiver. Run it again. The open bolt design meant debris had fewer places to settle, and the loose manufacturing tolerances that would have caused failures in a precision weapon actually worked in the Sten's favor. Dirt that would have bound a tightly fitted bolt passed harmlessly through the gaps. The weapon kept cycling. It wasn't flawless. The magazine was the weak point. Always. Double stack feeding required careful loading discipline. Overfill the magazine or allow the feed lips to take any damage, and stoppages became frequent. The safety system was minimal, a notch machined into the receiver body that the bolt handle rotated into, holding the bolt open. It functioned, but it wasn't robust. Later in the war, there would be documented incidents of Stens firing when dropped or jolted. An accidental discharge that more than once cost a soldier his life before he'd fired a single deliberate shot. But in July 1940, with German landing craft sitting in French harbors and invasion barges being counted by RAF reconnaissance aircraft, nobody was asking whether the Sten was perfect. They were asking whether it could be made, in volume, immediately. The answer was yes. The War Office took the design specifications and distributed them across Britain in a way that would have been unthinkable for any previous weapons program. Not just to arms factories, to bicycle manufacturers, to garage workshops, to metal fabrication shops that had never produced a firearm component in their existence. Any facility with a drill press, a basic lathe, and sheet metal stamping capacity could receive a production contract. Components would be made separately and sent to assembly points. The Sten had been designed with exactly this kind of distributed manufacturing in mind. It wasn't an accident. Shepard and Turpin had built the production system into the weapon from the very first sketch. The unit cost came back at approximately 10 shillings per weapon, roughly £2 in total production cost, around $10 in American dollars at 1940 exchange rates, against the Thompson's $209, against the Bren gun's £150 or more. The Sten wasn't just cheap. It was in a different category entirely. The first truly mass-producible automatic weapon Britain had ever fielded. The first production order went out in August 1940. By September, finished Stens were moving through the distribution system. The timing was razor-thin. By September, the Battle of Britain was at its most violent peak. Hurricanes and Spitfires were going up multiple times a day over southern England. The Luftwaffe was systematically attacking RAF sector stations, trying to blind the fighter network. German planning documents later captured showed that Hitler had set invasion readiness for mid-September 1940. He needed air superiority first, and Fighter Command refused to give it to him. Every week the RAF held, more Stens reached British hands. By the end of 1940, the production figures crossed 100,000 units. By mid-1941, that number was climbing toward 250,000. The broomstick army was becoming an armed one. For the Home Guard, those men who had been standing on coastal roads with nothing, the Sten's arrival was something that went beyond practical value. These were farmers, shopkeepers, retired soldiers, men in their 50s and 60s who had been asked to defend their country and given nothing to do it with. A Sten placed in a man's hands and a magazine of 9mm ammunition in his pouch changed something fundamental in the way he stood. It didn't matter that the gun looked crude. It didn't matter that the magazines needed careful handling or that the safety was basic. It fired. It kept firing. At 550 rounds per minute, a Home Guard section armed with Stens could put serious fire into any German infantry unit that came off a landing craft within effective range. They were no longer civilians waiting to be overrun. They were soldiers with something to say about the matter. Churchill grasped this from the beginning. The physical defense of Britain mattered, but the psychological state of its defenders mattered just as much. Men who believe they are already beaten fight accordingly. Men who are armed, even imperfectly, have a reason to hold. If you haven't subscribed yet, consider doing it now. We cover stories like this every week, and there's far more to come. The Sten moved outward from the home guard into regular army formations, and then into the world that most people never saw. The Special Operations Executive, Churchill's deliberately vague Ministry of Ungentlemanly Warfare, recognized immediately what the Sten could do for agents operating behind enemy lines. It disassembled in seconds into components small enough to be concealed separately. The barrel, receiver, and magazine housing could be wrapped individually and hidden in locations no conventional weapon could occupy. SOE agents parachuting into occupied France, Belgium, Holland, and Norway carried Stens in their equipment containers. Resistance networks across Western Europe received crates of them on RAF night supply drops. In the French countryside, operators working under the Gestapo's nose kept disassembled Stens in places that would never be searched, inside chimney stacks, beneath floorboards, in the false bottoms of farm carts. The loss of a Sten in the field wasn't the catastrophe it would have been with a conventional weapon. That was by design. A resistance fighter who lost or had to abandon a Thompson had lost an irreplaceable, expensive precision instrument. A fighter who lost a Sten had lost 10 shillings worth of steel tube. Another would arrive on the next supply drop. Shepard and Turpin had built disposability into the weapon and made it a strategic advantage. By 1942, Sten production had expanded to facilities across the Commonwealth. Canada was manufacturing them in significant numbers. Australia produced its own variants. And then something happened that neither Shepard nor Turpin could have anticipated when they first sat down at that drafting table in Enfield. The design escaped. In occupied Warsaw, the Polish Home Army obtained smuggled blueprints and began manufacturing their own Stens in the basements of apartment buildings, in concealed workshops, in spaces where a single wrong noise could bring the SS through the door. They machined the parts one at a time, assembled them by lamplight, and hid the finished weapons in places the German occupiers never thought to look. The weapons they produced were functional. They worked because Shepard and Turpin had made the design simple enough that determined men with basic tools in a basement under occupation could reproduce it without a factory. That single fact says more about the design than any performance specification ever could. The Mark II Sten appeared in 1942, the design pared down even further. The barrel jacket of the Mark I, a thin metal sleeve around the barrel that had added weight and manufacturing time for minimal practical benefit, was removed entirely. A simple perforated sleeve took its place where heat protection was needed. The magazine housing was made fully removable, allowing the weapon to break down into a package compact enough to be concealed inside a coat or a small bag. Fully loaded, the Mark II weighed just under 7 pounds. A soldier could sprint with it, dive into cover with it, drag it through mud on his elbows for 200 yards without it failing on him. It remained imperfect. The magazine issue never fully went away. Some units developed strong opinions about Sten reliability. Paratroopers at Arnhem, operating under extreme conditions far from resupply, reported frustrating stoppage rates in 1944. The accidental discharge problem persisted throughout the war, a consequence of the minimal safety system that Shepard and Turpin had accepted in the interest of simplicity and speed of manufacture. But 4 million of them were made. 4 million. From a design that Shepard and Turpin completed in 36 days, with no budget and no margin for error. Reginald Shepard died in 1957. Harold Turpin passed in 1964. Neither man received the kind of recognition that generals and admirals accumulated over careers. There were no statues erected, no public honors ceremonies, no streets named after them in the towns they lived in. Their names appear in the historical record on weapons classification documents and in the official design history of the Royal Small Arms Factory at Enfield. Not in headlines, not in the kind of books that get made into films. But their weapon was everywhere. From Tobruk to the Normandy beaches, from the jungles of Burma to the burning streets of Rotterdam. British paratroopers gripped Stens at Arnhem as the relief column failed to reach them. Commandos carried them on night raids along the Norwegian coastline. SOE agents fired them in safe-house confrontations in Lyon and Toulouse. Resistance fighters used them during the Warsaw Uprising of 1944, street by street, building by building, in a battle that lasted 63 days. Free French fighters had them in their hands when Paris was liberated in August 1944. And across all of those moments, across every theater and every campaign, the men who first received the Sten were the ones standing on English beaches in the autumn of 1940. Home Guard soldiers, men with no military future, no prospect of glory, no expectation of anything except standing their ground if the barges came. Men who had been handed broomsticks and told to practice. Men who, when the Sten arrived, finally had something real. They checked the magazine. They worked the bolt. They took up their positions along the chalk cliffs and the shingle beaches, and they waited. The invasion never came. History moved differently. But those men were ready. As ready as a Sten and a will to fight could make them. The lesson buried inside those 36 days in Enfield is not really about engineering. It is about the courage to throw away what is unnecessary and focus entirely on what actually matters. Shepard and Turpin did not build the most accurate submachine gun of the war. They did not build the most reliable one, or the most comfortable one, or the one that would have won any peacetime competition for quality. They built the one that Britain could actually have, in the quantities it needed, at the cost it could afford, in the time it had left before the decision was made for it. Perfection was not the goal. Survival was. And when the Stens reached the hands of men who had been holding broomsticks, when the first magazine seated and the bolt rode back, and the weapon sat ready in a man's grip, in that moment, Britain was a fundamentally different country than it had been the week before. Not saved, not safe, not guaranteed anything, but armed, and armed was enough to start.